Hello everyone. This is the video lecture for Math 1325 Business Calculus Section 11.1. We're doing first derivatives and graphs. So, it's been a while since I've done any more videos for this. So, for y'all, it might have just been 2 minutes. But for me, it's been a month or two. So I got my notes, and we're just going to have fun here. It'll be great. So, we're talking about the graphs of first derivatives, and I just want to say, like, going into it, if you have a graph that is increasing, like on the original graph, that means that the derivative is positive. And I think what I'm going to do is actually double arrow this, because if you have the derivatives positive, then the graph would be increasing. And I'm going to explain all this here in a second. If you have your graph, your original graph decreasing, then your derivative is negative. But you kind of probably already figured that out before I even said anything. So what does this mean? I'm going to do an example and show you, because I think examples are really awesome. So let's just say I have this cool cubic graph. Oh man, that's not cool enough, Chad. All right, well, that's still not great enough. Here we go. A little bit better. Come on. No, don't save a file. You're like, just get it over with. I know it's got to be perfect, okay? All right, there we go. Just making a big point out of it. And so I'm looking to see when this graph is increasing. And you can see it's increasing all this section over here. And then where is it decreasing? You can see decreasing right here. And then it's increasing again on this side. So this is my original, like, f of x. So then my derivative graph, f prime of x, is going to be positive over here up until basically this point, and then it'll be negative for that amount. And so this is just a rough graph here. I'm not going to take that many times this time. It'll look something maybe like this. Yeah, I like that. That's good enough. So let's do some other colors. Give me a second here. Let's do some blue. All right, cool. So you can see all this right here is that's such a dark blue. I can't have that. I clicked blue and okay, there. I want blue. That right there's good enough. Okay. So all this here, now I'm going to draw on top of the graph. All this here is increasing, and that means it's positive. So all this area would be positive, like right here. You can see that is positive. It's above the x-axis. And then I'm going to get a different color. Let's go red. So then we have decreasing here. This chunk right here is decreasing. So I'm going to expect it to be negative. And you can see indeed, this chunk right here is indeed negative. It's below the x-axis. And then finally, going back to blue, about right there is good. So then you could see it's increasing once again. So I'm expecting this to be positive. And indeed, over here on the side, you could see that it is indeed positive. So that's how this kind of graph works. We're looking at the slope of it. And again, this is just the slope. And seeing if the slope is positive or negative, just go ahead and put it above or below the x-axis. Because like right here, this is 0 essentially, right there. Okay, so real quick, I have one last thing. To find the mins and maxes, you need to find when f prime of x is equal to 0. So that's kind of like a formula, solve for x, essentially. Let's just talk really quickly about that. I mean, not that we're on a time frame here. You can always just 2 times speed me. So you could see right here is a maximum, and right here is a minimum. Max, min. And so over here, that's always going to be on the x-axis. Max, min. So if you look at the graph, the derivative graph, and you set it equal to 0, find out wherever the zeros are there, that would be where you have your mins and maxes. This is also called critical points. And there's a small distinction about that. I'll give you a little bit more definition on that here in a minute. But right now, let's just do mins and maxes, okay? So jumping in to the very first problem on the homework, 11.1.17. I don't know if this is number one on the homework. I was just saying like the first one that we're going to be doing here from the homework. So I have my derivative on a number line. And this one's strange because they give us like letters. I got A, I got B, I got C, and then I got D. And this is just going to be wild. Okay, so just kind of hang with me for a second. I have a solid circle thingy there, a solid, and then I have an open circle, and I have another open circle, and then I have another solid. And then it has negative, negative, negative. And then in between here, it's got positive, positive, positive. And then I have another positive, positive, positive. A negative, negative, negative. Finally, negative, negative, negative. Okay, so that's just weird, right? That's just so weird. I put some extra notes here, which might be mine. I don't think it's from my math lab. I don't think it's from the homework. So real quick, let me just dark blue should be fine. So I put a little 0 here, and then I put ND for like not defined, and then this guy is a 0. So these zeros here are legitimate points. Like in a way, these are the maxes and mins, and this is a max or a min max, and we're going to find out each one of those. This cannot be that way because they don't exist. Like those open circles say they're not actually there. I don't want to even attempt to draw this kind of graph. The main point is this: just ask these questions. So they're going to say min, max, or none for A. Did they say none? They have none. Okay. So and they're just going to go A, B, C, D basically. So which one is it for A? So we have negative, which means it's going down. And then we have positive, which means it's going up. And it's defined on that point. So you could see the curve here. It should be a minimum because basically you could see that parabola action, right? I'm not going to keep that there because it'd be junky. But if you're going down and then coming up, it's got that little curve there, okay? I think I'll leave that part. I like that. Okay, B, min, max, or none. Because to me, it's not defined. I would just say, oh, it's none. But that's not what they're going for here. So kind of just like roll with me, okay? I have the answers. We're going up, and then we're going up again. So this is an up, this is an up. And it's not defined on that point. This is kind of weird. Because they're both up, I would say none. Like I have little notes on the side talking about why it's happening, but I'm just telling you them. And then min, max, none for C. We're going up, and then we're going back down. You can see there's like a curve here, right? So that would be a maximum. Now, I know that it's not defined there, so I mean, I'm pretty sure the answer is max, even though it's not defined there, okay? So I'm going to put a little question mark. It could be a none just because it's not defined, but I think that's what my math lab had. If I'm wrong, put it in the comments, whatever, that kind of thing. But I'm just going to tell you like that idea is that definitely it's a maximum there. And then finally, this guy here, we're going down and we're going down again because you're both going down. It's definitely a none. So this thing didn't work. That was actually something. I don't know. Just whatever. None, because they're both going down. For sure it's a none. That's easy. Okay, cool. I mean, there's a lot of little tricky things on these guys. Just, multiple choice, click, click, click. Okay, so 11.1.29. I have my original f of x is equal to 9 over x plus 3. And they have a couple things they want to find. So part A says find the derivative. So we're going to find the first derivative. This is super easy. So what I'm going to do beforehand is I'm going to say that this is 9 times x plus 3 to the negative 1. And then to find my derivative, I basically just bring this negative 1 down. And then I minus 1 from the power. So that it now looks like this. Now with a square on the bottom. So like there's your answer. We're done. Yay. So this one has definitions that we have to talk about. So they're looking for partition numbers. Partition numbers of f prime. Now, what is a partition number, right? Is like definition. It's when your derivative is equal to 0 or when it's undefined. Okay? So derivative equals 0 or undefined. Basically, this is when the top is equal to 0, and this is when the bottom would be equal to 0. I don't have that in my notes, but that's what it is. So there you go. On my derivative. So if you're looking here, when would I like solve for x down on the bottom? When would I ever have that? And then we'd be at -3, of course. This one here, when is my top ever equal to 0? Like, when is -9 equal to 0? It doesn't work. So there's like none there. This is the only thing that actually is working. And what they actually want is the -3, just the answer, -3, you're done. Part C, they say now find the critical numbers of f of x. And notice there's slight adjustment here, that this was f prime of x, now that's just regular f of x. But critical numbers, what is that? It's going to be the same thing. So this guy's equal to 0 or undefined. Okay. But it's got to be in the domain of f of x. So I'm going to say included in the domain of f of x. And this is why, like right here, let's just stop for a second. This is why I'm kind of questioning this last question, if it's a max or if it's none. I mean, again, it's not defined here. Oh, that's the trick. Look, it's not defined on my derivative. Did you see that? My derivative, it's not defined. But that doesn't necessarily mean that it's defined or not defined on the original. Man, that is such a picky little thing there. So yeah, I stand by this max now a little bit more because, again, it's not defined here, but it could be defined on the original. Anyways, so I know if you're not catching what I'm saying, multiple choice, all right? And then down here, basically just do it normal. Like, we're just going to say if it doesn't work, it doesn't work. My original was that 9 over x plus 3. And the only numbers that could work is right here. So, like, these partition numbers are the critical numbers, except that we have to have this extra criteria. So I want to say the answer for this stuff here is going to be x equals -3. But when I plug it in, I'm going to get that divide by 0 stuff, right? Which is no good. So you can't use that. The actual answer here is none. I know that's so weird, but you have this answer, which is somewhat maybe legitimate, and then you go and plug it in to the original and see if you can use it, and I can't, so you just have to say none on that one. Remember that I'm doing the problems that I found were not super hard always, but maybe like weird. There's a whole ton of homework problems that I'm not doing. At this point, you definitely know that at this point. But I'm choosing ones that are a little easy to understand sometimes, but also like, what are they asking for? And then I get to talk about it with you, you know? So I have the original here, and they're wanting to find increasing, decreasing, and mins and maxes. So that's going to be a little bit of stuff. So increasing, decreasing, like intervals. And then they call it extrema, which means mins and maxes. Oops. Something kind of like that. Okay, so let's do this. So I need to find my derivative. So anyways, increasing, decreasing, extrema, all this stuff here is basically leading me to say I need my derivative equals 0, solve for x. Once I'm there, I can kind of start working with it. So let's find my derivative. So I got 3x squared plus 8, and I'm setting that equal to 0. Again, that's going to tell me the points at which it's changing, mins and maxes, that kind of stuff. You know what's kind of weird, though? And hopefully, I'm hoping you could see it already, but let's just keep going here. Divide by the 3. And so I got a negative Now I have got a square on one side and a negative. It's not good. This is bad. This is bad news. But I'm going to try it here. Square root both sides. Let me just conserve space for no reason. And you get a plus or minus the square root of a negative. And that's just, square root of negatives is not good. This is an I, like in, I would say like in other algebra classes or other calculus classes, you would get I. But that's not what we do here, I hope. So yeah, it's just none, no critical points. Now that's not the answer, but that's helping me understand something. So what are they asking for? What does it look like, kind of stuff? So I have increasing interval, I have a decreasing interval, and then they want those critical points, which again are like mins and maxes and stuff like that. Well, right now I could definitely say none right here, so that's easy. But what about increase and decreasing? Just because I have none of these doesn't mean it's necessarily this way or that way. What it is saying is that it won't change. So what we need to do is see if it's increasing or decreasing at all. And so what I need to do is test the number. I'm going to test x equals 0 because it's so basic and easy. And I just want to test it out with my derivative. So that would be 3 times 0 squared plus 8, which is just a positive 8. But the key is that it's positive, which means it's increasing. So it's increasing at 0, but there's no changes either. There's no switching. It's like doing this, and I know it's subtle, but it's never actually going down. It's actually going up. It's still going up, and then it's going up some more. It's going up the whole time. It looks something kind of like this. So it's always increasing. So what would you say for increasing is negative infinity to positive infinity? What would you put for decreasing? None. You have to click none again. I know this is so weird, but that's why I'm doing this here with you, because, well, it's on your homework, and otherwise you're like, what is he talking about? What's going on here? I'm wanting to do these odd problems once in a while. The next one's actually super easy, which is nice. I mean, these are all not too bad, but same as last time, they're wanting increasing, decreasing, and then critical points. I'll put CP. CP. Or maybe, because they call it extrema, EX. T. I don't know. Just making stuff up. Now, what you would have to find your derivative of this one, and that's not too bad. We could do that. So what's the derivative of e to the x? It's e to the x. Very good. The 2 comes down, makes a 14x, and we're setting this equal to 0. Unless you know what you're doing, which even I would have difficulty with this. We need to use graphing for this one, and thankfully on the problem itself, I'm pretty sure it says blah 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 blah, use graphing utility. So yeah, we're going to use Desmos, and that's why I have it up here. So e to the x minus 14x, and we're looking for when it's equal to 0, and boom, boom, we're done. So those are my answers, 0.08, and then 4.03. And that's it. I mean, depends on what you're rounding to, of course, but ta-da! That was it! Oh, wait, that's part A. Like, I'm looking around like, what? That really was it? No. It's not it. Part B, it's wanting the increasing, decreasing parts and all that stuff. We'll get to the extrema here in a second. I think that, like, those are it right there, essentially. So increasing, again, this is my derivative graph, and I'm still zoomed out, but you're kind of getting the picture. It's a parabola that kind of does this here. So notice that all of this is positive, and this is positive. So those two intervals, those two sections, are going to be increasing. Like, I'm literally just looking for positive and negative on my derivative graph, okay? So positive would be negative infinity up until that 0.08, and then union, we start back up at 4.3 and go off to positive infinity. Again, it's not going up and like this saying, oh, that's positive infinity. No. Positive infinity is going this way. This is positive infinity to the right, and negative infinity is over here on the left. Remember, we're doing x values, okay? Yeah, they're both going up. That was the whole point. That's why it just says increasing. But I'm looking for left and right. So this is saying left, and this is saying right. I know that you probably know that by now, but I'm just reminding you because these kind of things are important, okay? And then, of course, in the middle, right here, you can see that it's all negative. So that would be the decreasing part. And we're just saying between those 2 points that were given, you're done. That was it. So very simple. Those are my answers. All right, cool. It's all wrong. What? Gosh, Chad, why do you do this to me? Oh, I know. Okay, hold on. It needs a comma. Oh, why not a union? I don't know. Comma separated. Apparently I wrote a note for myself because I had a union and I erased it, and I have a comment and it says comma separated. So like, yeah, it's just them doing their thing. Okay. Part C was the min and max, I think. Oh no. Give me a second. Hold on. This was part B. This is part C. B, C, and then D. So D, it says mins and maxes. So where's the max? Is that x equals what? And then the minimum is that x equals what? And so looking here, again, we're going, this is increasing to decreasing. And then I'm going to go from decreasing to increasing. So I'm going increasing to decreasing, and then I'm going to go decreasing to increasing. So this is going to be a max, and this is going to be a min. So then I'm just going to pop them in, and we're done. 0.8, and then the 4.03. Okay, but here's the thing. Yeah, that's cool. Thanks, Chad. Can I just do the original? And yes, the answer is a yes. If I went back and did the original, you hopefully should be able to see, that's a 7, the original graph, and you can see there's a maximum, and then if you scroll like, there's your minimum. Right? Maximum, minimum. All right. It's not too bad. I have only 2 more problems left. So 11,177. So they give me the graph of the derivative, and I'm going to try to be really good with this. So 1, 2, 3, 4. I think it's 5. It's 5. Okay. So use a different color here, real quick. Guess blue and pink are my colors today. So it looks kind of like this, and then it comes up and touches, and then it goes back down like that. Okay, sweet. So there's my graph, and it says that this is the derivative. So part A, it says, when is it increasing? As in, and this is where it's, oh, no, yeah. When is it increasing? When is this positive? And you can see it's positive over here. This is that part. So negative infinity to -1. Done. Okay. Part B, decreasing. This is where it's negative. And so it's kind of broken up here. You have this part right here, but then you also have this. And you're thinking, well, the whole thing, Chad. -1 all the way to infinity, right? Because it goes on forever this way. That's mostly not right, because right here it's touching at 0. And so it not, okay. Yeah, it's touching at 0. But it's also a maximum. And no. It's touching at 0. So it's literally like right here, it's not negative for like that one little place. So we have to do up to 5. That's a 5, by the way. And then comma separated 5 to infinity. Yeah. Because there's a 0 right here. It's not because it's a max. It's because it's 0. So yeah, kind of weird. Because again, we're just saying, when is this thing positive and when is this thing negative? That's all we're asking for here. Okay. And then part C, it says there's a maximum at, and I have a box around x equals, I'm not really sure why, but let's talk about this here. So I have a maximum at, I have it right here at -1. And the reason why is because all this is increasing. and then I'm going to decreasing. It's like here, increasing to decreasing. See how I'm going to have a max? So that's -1. But you would think that then I'd have a minimum somewhere else maybe. And so you're eyeing this thing. You're like, what's going on here at 5, Chad? Because it's touching at 0. Well, the thing is that I'm decreasing here. This is all decreasing zone, and then this is all decreasing zone. And you gotta like wrap your mind around it. And I often get that confused myself. So that's increasing. This is decreasing, decreasing. I'm going decreasing, and then I'm decreasing. So like if I wanted to zoom out, what it actually looks like is like this, and then it does more of this. It might like settle for a second, but it won't actually go back up. It's just like this point where it's kind of like level for a second, which is still not a minimum or a maximum. So it's going down, going down. I don't really know what else to do there. So there's just none. There's just none, and there's nothing you can type about it. You just say -1, you're good. I know it's just so weird. So just like keep in your mind that you're doing positive and negative, okay? So this is positive, so it's going up. This is negative, so it's going down. This is negative, so it's going down. This is negative, so it's going down. All right. I know. And this homework section will be done here like right now. So this is the last question. B prime of t is apparently the rate of change for bacon prices, bacon prices. So, and they give us this graph, and I'm going to try to do it right. So here at 8 and way over here at 32, we have a graph, and let me change my color again. Let's do some green. Sounds pretty cool. Hopefully it's not too bright though. I don't want it bright green. I want it like a dark green. It just doesn't show it very well. And so it looks kind of like this. This is the graph that they're giving you. Something like that. Okay. And this is B prime. Okay. So this is my derivative. Again, notice that we have negative, positive, negative. Okay. So if you think about it, this right here means that it's decreasing. This is increasing, and this is decreasing. So if I like zoomed out, what would my original graph be? Decreasing means I'm going down up until 8, and then I'm supposed to be increasing, okay, for a while until the 32, and then I'm decreasing again. Now, again, we're gonna draw what it actually looks like now. But if you're thinking about this as like bacon prices, they're never going to be negative. Like they're not going to pay you to take their bacon. So it's always going to be up here, positive zone, just because it's prices, just bacon prices. That's just, I'm telling you, that's how it's going to have to be because like that's reality. So it's going to look kind of like this going down, and then it's going to go up for a little bit, and then it's going to go back down like that. Okay. So again, this right here, it was going down, decreasing because this was negative. This is going up, I guess, until like that point. I know it's a little weird, but that's fine. And then it's going up, increasing because all that's positive, and it's going to go back down. So this is my graph, and it's not perfect. Let me make a really much better graph. Okay, so here's your 8, here's your 32, and it's going to go down, and it's going to come up, and then it's going to go back down. Okay, so there's the original. Sweet. I think that's actually the answer. That's all they're looking for, just A, B, C, or D. There you go. I guess you could also say, oh, there's another part to it. So this is going to be a minimum, and this is going to be a maximum on my original, because this is my original. Oh, it's not F, Chad. It's B for bacon. All right. There you go. Yeah, that's it. We're done with this. So thank you very much, and have a great day.